Now let's ask, how many possible pictures could we make if we choose to photograph only 3 of the 5? Now we'll make an observation that the order matters, but we choose only 3 people. So we choose 3 of the 5. Order matters. Well, again, we're going to think of filling in slots, but now there are only 3 people to choose, so we're going to only have to fill 3 slots. So we'll have person 1, 2, and 3. Okay, slots 1, 2, and 3. How many possibilities are there for who goes in the first slot? Well, there are 5 possibilities. For the first slot, because there are 5 people to choose from. Having picked that person, there are only 4 possibilities for the second slot. So we're going to have 4 here, and of course that leaves us with only 3 people left to choose from for the third slot, so that the number of possible pictures is going to be 5 times 4 times 3. So there are 5 times 4 times 3 possible pictures. Now it's going to turn out that we can compute that number using factorials. Let me just change the R, because this word looks pretty much incomprehensible the way it is. And then we'll see how we can use factorials. Oh, boy, I got a glob of stuff. Yeah, that still works. Someday somebody will come up with a good whiteout brush. Okay, let's get a piece of blank paper here and go on with this just a little bit. How could we calculate this number 5 times 4 times 3 using factorial notation? Of course, we could multiply that out. That equals 60. We note that this looks like a factorial, but it's cut off. It's cut off at 3 instead of going down to 2 and 1. Well, let's just observe something. 5 times 4 times 3 equals 5 times 4 times 3 times 2 times 1, which is 5 factorial, divided by 2 times 1, canceling out the 2 and the 1. And of course I know that the 1 is kind of redundant here because it's a multiplication, but just to see the form of the thing, we're going to write it this way. So that when the 2 and the 1 cancel out, we're left with just the 5, 4, and 3. Well, now this is the same as 5 factorial on the top. What's the bottom? Well, that's the same as 2 factorial, isn't it? So if we do 5 factorial divided by 2 factorial, we get 5 times 4 times 3. Now we're going to extend this just a little bit to the idea that what we've done is we've chosen a permutation of 3 objects, in this case 3 people, chosen from 5. Now the language the text uses, and it's very common language that never did make sense to me, and maybe that's my shortcoming. You say this is 5 objects taken 3 at a time. Now that seems a very confusing way to say it, but if that makes sense to you, go ahead and use it, and you might as well get used to it because you're going to hear it again. I call it the permutation of 3 objects chosen from 5. I don't see, and if somebody does, please correct me on that, email me, whatever. I would love to understand that language that the text uses and everybody seems to use. That language was a stumbling block to me when I tried to learn this stuff the first time. Okay, in any case, permutation of 5 objects chosen from 3. The word permutation means order matters. Okay, so in a permutation, order matters. We write that as P of 5, 3. That's what we mean. And that equals 5 factorial over 2 factorial. Now, how do you get 5 and a 2 out of a 5 and a 3? Well, there's another way of writing that, and it's really kind of the definition. That would be 5 factorial over the quantity. Wrote that wrong. Make this 5 minus 3 factorial. So the 5 and the 3, you subtract the 3 from the 5, and that's what you divide by. And if you think back to what we're trying to do and why we're trying to do it, it makes perfect sense that that's what we should be doing. So that the 5 factorial over 2 factorial would be written as 5 factorial over, I almost did it again. Actually, I did it again, but let's make that a 5 minus 3 factorial. 5 minus 3 is 2. That's what we want to divide out to cancel out the last 2 elements. Note that if we subtract 3 from the 5, that has the effect of leaving us the first 3 numbers, 5, 4, and 3. Okay, so 5 minus 3 will cancel out the last 2 numbers, leaving us 3 out of the original 5 numbers in the first permutation, in the permutation of 5. Okay, in general, we're going to say that the permutation of R objects chosen from 3 is, just generalizing this expression, P of nr will be n factorial divided by the quantity n minus r factorial. And there's our definition of permutation. If we have this many objects, and I'm not sure why I wrote 3 here, but it should be chosen from n objects. Getting a little close to supper time and there's not as much sugar in my brain apparently. My blood sugar's getting low. Okay. That's my excuse anyhow. Okay, so permutation of R objects chosen from n. If we choose this many objects out of this many, and if we put them in an order that matters, is distinct from other orders, this is how many possible ways there are to accomplish that.